So in this video, I'm going to cover problem 15 from chapter 8. So they give us these returns for Apple, AMD, and Oracle, and they give us 9 years of returns. And they want us to create an index fund that is tied to the information technology S&P. Okay, so I've got all my data, plugged in, right? They give us all this, so I got all plugged in. Although there is one thing I want to point out. Obviously, before I started this video, I made sure I did everything correctly, and I didn't put the IT S&P in correctly, right? Because the book, they kind of trick you because they give it to you in percentages. So, like, if you look at your book, it's like 28.54%. But see, then they give you all of these returns in decimal form. So you cannot put in the IT S&P in percent form when all of these are in decimal form. So be careful with that. That tripped me up when I first did it. All right, so anyway, I got everything plugged in. And then, of course, I have my choice variables, right? So this is the percent of Apple that I would purchase. This percent of AMD, percent of Oracle, right? And then here, I need to calculate my returns for the various years. So this is going to be a sum product function. Sum product. Okay. So if I get the returns in year one, right, this is what I'd get. And then, of course, multiply that by how much I'm investing in each stock. And then I want to anchor this. So I'm going to anchor my choice variables here. And then, of course, I just want to copy this down. Okay, so this is what I would get if each of these scenarios occurred, all right? And then we need to calculate our squared deviations, right? Because we want to minimize the squared deviations between the return in each year and our index. So here, I'm going to take the return from year one minus the index from year one, and then I'm going to square that. And then again, I can just copy this down. Right, so there are my squared deviations. Don't worry about this. This is just scientific notation. Basically, it's 0, right? 9.8 times 10 to the negative 5th power. That's pretty close to 0. Okay, and then my objective function is I want to minimize the sum of those squared deviations. So here, just sum those guys up. Sum. All right, and then lastly, I've got my constraint, right? In this problem, the constraint is implied because our choice variables are percentages and they must sum to 1. So I'll calculate that real quick. Sum these three. Come on. Must equal. Oops. I hate that. Those three, the sum of those three must equal 1. All right, there you go. And then I like to do this. You don't have to, and this is not part of the problem, but I do like to take a look at the difference in the returns relative to my index. So all that is my return minus my index. And really, it just tells me how close I am in each scenario. Okay. At any rate, there you go. That's all you need to do to run this problem. So now we just go into Data, Solver. Okay, so I want to minimize that function by changing these 3 cells and then setting this equal to this, and you're done. Non-negativity, check. Non-linear, check. Solve, And there you go. So what we're going to do is we're going to invest 28%. Sorry, 28% in Apple, about 1% in AMD, and then about 71% in Oracle. And if we do that, right, we're gonna the min of our sum squared deviation is going to be 0.41. But see, most importantly, we're really going to our expected returns, right, are going to be really close to the real returns. Now, some of them are a little bit off. I confess, year one, not good. But here we're pretty close. Not good. Not good. Here, we're close. Here we're close. Here, not so good. But we are minimizing the sum of the squared deviations. So, and that's why I like looking at this, right? Because, what this is telling me is that, in year one, the IT S&P returned 28.54%. But if we invest in these proportions, we're going to lose 5% in year one, right? That's why I have the negative 0.33806. So not too close, right? There's definitely some years where we're off by a little bit, but nonetheless, it still works. So there you go. There is our index fund. It's as simple as that. You just have the one constraint, and presto, you're done.